Hey, I just wanted real briefly to cover how to do logic in Minecraft, digital logic. It's not as hard as you might think. You use a lot of videos online showing very detailed and complex examples involving many little gates and arrays and stuff. Anyway, this actually might look intimidating by itself, but I promise it isn't that bad. So there's really only three types of gates we need. There's this OR, which I use right here. Very simple, literally just an input and another input that culminate in an output. And just so we can test the OR itself, let's just add some levers there. So if that one's on, output's on. If that one's on, output's on. If they're both on, output's on. But if they're both off, output is off. So the only case that output is off is when they're both off. This right here is an AND, so a little fancy setup here with 3 blocks, and it takes up one more row because you need a redstone torch on that block. But the output is like that. Anyway, the way this works, so they have to both be on for the output to be on. Oops, what? So that one's on, output's still off. That one goes on, now the output's on. But if only one of them is on or they're both off, the output's off. Not that bad. The final and most challenging gate is this exclusive OR here. I'm just going to use the original, these two inputs. So this is to demonstrate this one. But this is input A, this is input B. And I promise you that this one does actually go to this through some machinations. But if you turn this one on, you'll notice output goes on. Turn it off, output goes off. What's different, and again, this one's equivalent, so if you turn that one on, it goes on. But if they're both on, the output is actually off, which that's what differentiates it from a regular OR gate, is that it's an exclusive OR, meaning it excludes whatever, the case where they're both on. It actually turns it off. So if you arrange them this way, as I'm going to briefly outline, you can create a 1-bit adder, which has 3 inputs, A, B, and a carry input, and 2 outputs, a value, 1 or 0, and a carry bit, which is also really a 1 or 0. So you take 3 1-digit numbers, and you can add them together in such a way that you create one 2-digit number. That's what this logic performs. So I mentioned this first XOR right here. We're going to feed that output to 2 different places. First of all, it's going to be to this second XOR, and we're also going to boot it around over here, and we can delete that, that's not necessary, to this AND gate. And really what we want to do is mostly look at the first 2 gates in my setup, but I'm going to explain the whole thing first, and then I'll go back and maybe explain why it is the way it is, right? We don't need that either. Yeah, so this XOR feeds out directly into our value output. So, and then this one is an AND gate. As I said, it takes the input of what came from our first XOR, as well as this carry bit that I've added over here. And it feeds into this OR right here, which is the OR of way back to here, this AND gate, and that AND gate. So the 2 AND gates get ORed. So you have to think, in terms of 1-bit addition, like let's say we have no carry bit, what would we want our value to be? Well, in the case where it's 1 and 1, we get 1, 0, so we'd actually want it to be a 0, right, which is what an XOR is. 0 plus 0 is 0, of course. 1 plus 0 or 0 plus 1 is going to be 1, which would mean we'd want this on. And again, that elusive third case is the kind of confusing one, right? Because if you have a 1 and a 1, it's actually supposed to output 0, but there is a special case thing that happens where now you've got that 1 in front of it. That's what I'm talking about when I mean the carry bit, right? 1, 0 is equal to 2. And so we need to somehow trigger that carry bit as well, which is why we've got this thing going off that XOR output, sorry. Yeah, so the XOR actually outputs to two different things. It affects a couple things. We XOR both our inputs, and we send it over here to the second XOR. But we also send this one over here that affects the carry bit. So I mentioned the carry bit, right? When is the carry bit going to be active in terms of our two original inputs? Well, it's going to be active when they're both true. The only case where you can get 2 is when you have 1 plus 1, right? I think that makes sense. It's pretty clear. That's the only place where you can get a 2-digit number from a 2-bit input, or from two 1-bit inputs, I should clarify. Only case you can get 2 bits from two 1-bit inputs is with a 1 and a 1, which would make a 1, 0. So that's the only time you're going to have that carry bit, that carry output, I should say. But this third input here, this carry input, which could be coming from a previous edition of this exact same circuit, I might add, is what complicates things a little bit. And that makes it so that, yeah, things are just a little bit hairier. If you want, I will actually extend this circuit to be a 2-bit adder. So this is the full adder, and then I'm going to have to build a half adder in order to satisfy the rest of this design requirement I've just created for myself. So to demonstrate, remember what I just said about the and the XOR and how that forms an input. Yeah. Okay, so just making a bridge for myself. So that carry input, you'll notice I destroyed it, and I'm going to make it the carry output of the previous thingy. I don't really know what I'm doing. This doesn't need to be this long. Let's just build it over here. So, like I said, when should the carry bit be true? It should only be true in that AND case where both of the input bits are true, right? So that's going to look like an AND gate. That's what that is. Sorry, it should look more like that. And then this will... And one thing I am going to do is run a bootleg of my B input underneath my A input over here for this second, this half adder concept that I'm building now. Cool. So I've got a nice bridge. Again, that B input, need to get it around my A input here. Do I? Actually, I think I want to go the other way with this. What am I doing? So I've got the AND done, but I need an XOR over here. Pretty sure that's how it's supposed to look. And then I do like skip a few, right? So there and there, I think. Yeah, that's about right, actually. Looks like I add redstone there and there. A gate, torch there as well. And wire going over the top. Okay. And then the output is that. So that's my XOR. So what is my XOR going to go to? My XOR is really just going to go to the third bit output, right? That's all I need, remember, because the XOR, you know, is essentially what the lowest common, the lowest value bit should be So I'm just going to bridge that over. Boop. Okay, well, let's do this shit again. Hit that there. And eventually we're going to get it over here, I promise. I think I put a delay on that. Okay, yeah, I don't really want that to happen. Someone could make this look better, I'm sure. I just am not interested in doing so. Okay, so that's pretty much all we need, I think. We're gonna maybe bootleg our input a little better here, but that shouldn't be too bad. So as I mentioned, that B is being swung all the way around my underneath my A there, and so I can use it again there. I'm gonna run times that day. And then my A can come all the way around to here, and I use it again in that XOR. So this is for the lower bit, that little half adder I just built on camera, and then the full adder I built before is controlling the other stuff. So really there's only 4 inputs now, you'll notice. This is the higher input, right? So let's really talk about what this is. Let's say I want to do 11 plus 1, right? That's what I want. Or we want to do 11 plus 1. So this is a 1, and then we're going to come over here and do the 1 in this slot as well. And this is going to be a 0, 1 for 1. So a 0 on that one and a 1 on that one. So 0 plus 11, what did I say that should be? I said that should be 1, 0, 0, right? And yet that's not what we're getting. So I'm going to have to debug some stuff here. Shouldn't be too bad. I think I can probably figure out what's going on. It's probably that one of my repeaters is dying. Yep, or maybe it's that this isn't connected all the way through. Yeah, that's definitely dying before it gets anywhere. Alright. And it looks like now we've got something a little more interesting, right? Did 11 plus 1. Okay. I'm not entirely sure about that. Something's probably still wrong. Let's try it for some easier cases, just because I want to see. Yeah, so something over here is not making it to the output at all. That's an AND gate. This should be on. I think it's dying. That's an AND gate. Why is that not on? We'll figure it out. Give me a sec. Oh, I think it's that I need redstone torches there and there. Is that not it? Oh, I've designed this completely wrong. Ooh, no, that's not what I wanted either. So, ignore that AND gate. That's not what an AND gate is supposed to look like. Like that. That's kind of what we want. Ooh, what did I do? God, oh my gosh. Why does it destroy the whole block? It should just kill the torch. Okay. Man. I want a wire in between that. Boom. Okay. I don't even know what I did. Why is there a redstone repeater on my left hand? I didn't even know you could do that in this game. They changed it. I can tell you that much. let's reset our machine to 0. I still don't think it was making it to the end, so let's follow this. Okay, it looks like that is making it to the end, because that and's going to be 0, but it does trigger this guy, which goes all the way through. Good. What about this lower digit? Okay, it does make it through to the end. Looks good. I'm just going to assume the whole machine works and demo it now. So 1 plus 1. Did I already show that? I guess I didn't. So I did 1 plus 0. Now let's do 1 plus 1. It doesn't get all there. So this case isn't working. So I should have it carry. This and comes off, but it dies before it gets anywhere good. That's going to be our problem, I think. Although I need a repeater because I don't know how to get it out of this stupid hand thing. Okay, I guess I can do that. I don't know why they changed this game so much. It used to be fine. Looks like it's dying again. That's not going to work because the stupid redstone rules. What if we do that? That gets there. Okay. Again, I don't actually have logic gate errors in my my little code here that I've built. It's really just a matter of the repeaters not being like long enough, or you know, finely spaced together enough. Like they're too spaced out. So 1 plus 1 is 1 0 or 0 1 0 in this case, right? If you do just 1, it's going to be 0 0 1, which makes sense. But what if I did that 1 plus a 1 0? Well, you get a 1 1, which makes sense. 1 0 plus 1 is 1 1. What if we did a 1 1? Or yeah. So let's just go. Let's add it up slowly, right? So we've got 3 now. So how could we get 4? We could get 4 by turning this one off and adding 2 2s together. Because there's no way we can add 3 of something like a 1, a 1, and a 2. Because 2 is really the, or 3 is really the maximum number we're working with here is 1 1, right? Anyway, I don't know if I said that right, but whatever. I'm gonna move on. So, like I said, how would we make 4? Okay, so these 2 bits, I should explain this. These 2 bits are each worth 2, and these 2 bits are each worth 1, right? So the way we would get 4 is by adding, oh god, either a 1 and both of these. That gets us 1 0 0. Or we could turn both of these off and then have both of these on. Because, again, I said these are both worth 2. That'll get us 1 0 0. So how can we get 5? We could add 3 plus a 2, right? So these are each worth 2, as I said. But if we wanted to make one of them worth 3, we could do that. And we'll get 1 0 1. Looks like we do. And if we wanted... well, I suppose if we wanted a 6 is next, right? What am I thinking? So 6 is the maximum achievable number, because the biggest number we can add in each input is 3. This is input a power 1. This is input a power 2. This is b power 2. And way over here is b power 1. So the maximum number we can achieve is 6. And so let's say we turn this one on, we'll get 6, which is really just 1 1 0. So in terms of output, this is worth 1, this is worth 2, and this is worth 4. Right? So 6 looks like 4 plus 2. And we have definitely, I've checked every single case, we've definitely successfully implemented a 2-bit adder. Right? Really, it's, yeah, so 2 bits of input for 2 different inputs will give us 3 bits of output. Unfortunately, there's not really a way to create a case where there's 7 or more, just because each of those 2-bit inputs has a maximum value of 3. But if you did have a 7, it would look like that. It'd be 1, 1, 1. And then if you had 8, it would look like, just going to cheat a little bit here because I don't care about this circuit anymore. It would look like that, because at that point you would need a whole new digit because all of the others are filled up. If you didn't understand this video, you should go learn binary, and if you still didn't understand it, you should read more about the logic gates I've mentioned, which, to be clear, are XOR, and OR. Those are the only 3 you need. The XOR is the only hard one to build, I would say. So you can build something like this. You can look up a lot of different things, but if you wanted to do a little bit more learning, you could build something like this, or you could fuck around and try to build a memory cell, which can actually store a value indefinitely. That's the kind of complicated task that I'm gonna task you with. So research a combination of logic gates that will allow you to create a memory cell and build it in Minecraft. Yep. Take care. I'm done with this.